It is 11:15. It's 11:15 now. It's my turn to talk. So I'm circulating two sheets. One is your homework. That was the paper you read. Everyone has 10 points out of 10, so you don't have to worry. Even you should get it. The second sheet has a copy of the grade book, so you can check if the scores we have for you or Mr. Lowe has for you are correct or not. If there is any discrepancy in the scores, then you can see him. You should take a copy of your homework and or the test in which you have discrepancy to him so that he can correct it. There are no names on it. I cannot write names because of the privacy laws. The US government regulations do not permit us to write names and tell score of one person to another one. So the hint is these are alphabetically arranged. So if your last name starts with a Z, you should look at the end, and if it starts with an A, you should look at the beginning. It's very unlikely that any two of you will have the same scores in all tests and all homeworks, so you should be able to identify which row belongs to you. If you have difficulty in identifying, please see me after the class and I can tell you which row belongs to you. Okay? So, yes? The last column is out of 80. Because that's what we agreed on, 40%. And for the people in Wake Forest and Mr. Kunz at Oak Ridge, Norma will email to you a copy of this sheet. I have given to her, but I do not know what time today she will email it to you. So she will email to you your test as well as a copy of the grade book I am handing out in the class here. I think Ganesh has a question.
Is the final homework 11 going to be graded? And
yeah, it will be. This is as of today. Of course, we cannot give you any score for the homework you have not submitted yet. So that, yes, that will be included in this, and this sheet will be updated. Michelle, yeah. I think so, yeah. Wait. It is in alphabetic. The first column is alphabetically ordered according to your last name. Yes. So I think you are having difficulty.
I see the grade. There's like.
Oh, but your husband is not there. There is only one Cooper's grade here. There is only one Cooper here, and there should be two of you, right? Oh, the other one doesn't exist. Pardon me? I know he's sitting next to you, but I don't see. Do you use any other name?
No, my main name's still a P. It's Friday.
No, but does he use another name? No. Oh, I don't know.
I think it's down to the bottom. I mean, it's great.
Down towards. Oh, yes.
Yeah.
Yeah, I don't know why one Cooper is at the near the bottom and one Cooper is near the top. I do not know it. Okay. Yeah, so one Cooper. You are near the bottom. Michelle is near the bottom, and you are near the top. Hey, it's my turn to talk. Remember, the rules of the game are after 11:15, I get to talk. You can only raise your hand and ask a question, but you are not allowed to talk in the class. That was the rule of the game, right? I gave you in writing on the very first day. Yes.
Okay, Professor, I'll try to make just a question. Because I don't understand, because these columns are squared.
The columns which are in this first one is out of 40 for the homework. The other one is 40% out of the two tests. If you add them up, you should get the last column. Any other question you have about this sheet? And if you find this is not correct, because one of you sent me an email saying, am I reading my score correctly or not? So if you think that your score for any homework or the test has not been recorded properly, please see Mr. Lowe this week. After we assign the grades, we will not change it. Changing the grades is it's a lengthy process, in the sense it takes many people to sign the sheet of paper, and the department doesn't like it. So basically what happens is every person who signs it takes away 5% of my paycheck. So if 20 people sign it, I get 0, but I think only 5 or 6 people get to sign it. So I lose only 30%. I'm just kidding. Anything else?
Yeah,
No?
sorry, Professor.
Yes.
Just another observation. I noticed that, unfortunately, they didn't put online the lesson of December the 3rd.
December 3rd.
Yeah, could you make
Yeah,
something?
I will contact them. Yeah.
Thank you.
Yeah, sure. Okay, anything else you want to know? There's one more class on Wednesday. All of the material covered through Wednesday can be on the final exam. Okay, so it's up to you whether you wish to pay any attention to it or not, but it can be, okay? So I think some of you expressed an interest in studying viscous materials. So that's what I'm going to do now. So thermo, elasto, viscous materials. You can see 3 adjectives. Thermo, which means we are considering temperature changes. Elasto, that means we have elastic deformations. And viscous means we have viscous deformations. So we will be able to cover, I don't think I can go in all the details, but we will be able to cover viscous fluids as well as viscoelastic materials like polymers. So the stresses can depend upon temperature, strain, and viscous means strain rate. That's where viscosity comes into picture, right? Means strain rate. So our constitutive assumption is that the free energy phi depends upon deformation gradient F, its time derivative, and thus through what the viscous effects is coming into picture, and the temperature gradient. So this is a class of materials for which the free energy, entropy, first Piola-Kirchhoff stress tensor, and the heat flux depend upon F. There are 9 components of F, 9 components of F dot. That makes 18. Temperature is 19. 3 components of temperature gradient in the reference configuration. So that's 22. So each one of these quantities depends upon 22 variables. Okay. Previously we have seen like stress depending upon strain and temperature. So that means stress depends upon 7 variables. Because strain we derived, it came out to be a symmetric tensor rather than the F we are considering here. So stress was a function of like 7 variables. And so was free energy. However, the heat flux was a function of more than 7 variables. It was a function of 10 variables. Okay, so this is a thermoelasto visco material is such, or is one for which the free energy, entropy or specific entropy the first Collier-Cox stress tensor and the heat flux in the reference configuration depend upon F dot, theta and G. We are assuming that the body is homogeneous. So all materials of the body, all points of the body are made of the same material. Otherwise, dependence upon the material particle will come into picture. So we are not talking about inhomogeneous bodies. So the first principle we have to obey is what? So what do these constitutive equations must satisfy? Energy balance. So what do these constitutive equations must satisfy? I mean, I cannot write any function I like. Yes, Josh? For entropy inequality, very good. So the first thing is they must satisfy the second law of thermodynamics, which is in our case entropy inequality. If they do not satisfy the entropy inequality, you can forget about that constitutive relation. Okay, it's not thermodynamically admissible. So the first thing is entropy inequality. So in our case, we wrote the entropy inequality, or we derived it, or wrote it, whatever you wish to say, in the reference configuration as phi dot plus eta theta dot minus TIL tilde FIL dot plus QL theta comma L, which is the same thing as G, and GL is delta theta over delta XL, which we are denoting by theta comma L. So that's the reduced entropy inequality. I think my memory is correct. Is it okay? I mean, I realize you may not remember it, but anyway, that is what we derived. So the difference is, like it's Clausius-Blum inequality, except that the source term R has been eliminated by using the balance of internal energy. Katie, you don't seem to be very happy. It's okay? So let's now substitute for phi. Oh, sorry, you can't see it. Oh, boy. Anyway, I need to substitute for phi, so you basically have to remember phi is a function of f dot theta and g. Because there is no way, as soon as I move this paper up, you won't be able to see those f dot theta and g. So this is rho 0 delta phi. I'm using chain rule of calculus plus delta phi over delta FIL dot FIL double dot delta phi over delta theta dot plus delta phi over delta GL dot plus eta theta dot. Now I close the parentheses. So minus TIL tilde F dot IL plus QL GL over theta is less than or equal to 0. So all we are doing is substituting for phi, the Helmholtz free energy. And using the chain rule of calculus to evaluate phi dot. Using the chain rule of calculus to evaluate phi dot. Okay? This quantity that I have enclosed in the box depends linearly upon f double dot. It depends linearly upon f double dot. So I can make f double dot any number I like without affecting anything else, and I can violate the inequality. Remember, f double dot can be made very large, negative or positive. If I change f double dot, nothing else will change. So I can violate the inequality. Fred, is it okay? Therefore, the quantity in the box must be 0. So we got rid of phi cannot be a function of these 9 variables. The Helmholtz free energy cannot be a function of f dot. Also, we have a similar situation here. I can change g dot any way I like and violate the inequality. So therefore, the quantity in the green box must be 0, and then phi cannot be a function of the temperature gradient. So basically what we are saying then is that phi is a function of f and theta only. And that was the case for a thermoelastic material. Phi is not a function of f dot, and phi is not a function of g. What about these two quantities? So if I combine these two, they depend upon theta dot linearly. So I can do the same thing. I can change theta dot any way I like. So that really means eta, the specific entropy, must be a function of this. And in the final exam, if there is a question, I do not know if there is or not. If there is a question and you are given phi and you are asked to find eta, the relation E equal to phi minus eta theta will not be acceptable. So this is what you have to use, or you must use. I will try to rephrase the question so that there is no ambiguity left there. Pardon? So if there is, I will try to remove that ambiguity. Okay, so what this one says then is that eta is also, that entropy is also a function of f and theta. Because phi is a function of f and theta, so entropy cannot be a function of f dot and g. Yes?
How can you assume that those are equal to 0 when you have an inequality? Why are they not less than or equal to 0?
Because I can violate the inequality.
But if they were just assumed to be less than or equal to 0, then it would still satisfy it.
No, like supposing this is less than 0, right? Then I can make g dot less than 0, and this will become positive, right? Remember, g dot is your choice, theta dot is your choice, and f double dot is your choice. Okay, so what we are left with is the remaining terms, and that is rho 0 delta phi or delta FIL dot minus TIL tilde F dot IL plus QL GL over theta must be less than or equal to 0. This is not linear in F dot because T tilde and Q depend upon F dot. The left hand side is not linear in F dot. Even though you see F dot here, but T tilde depends upon F dot, and Q, heat flux, depends upon F dot. So I cannot change F dot arbitrarily, because if I change F dot, I will change the stress also, and I will change the heat flux. So let's call this R. The whole thing, all three terms combined, let's call it R. So when is R minimum or maximum? What is the maximum value of R? 0. So the maximum value of R is 0, and when does it occur? What should be F dot and G for R to be 0? Yes? What should be F dot and G for R to be 0? 0. So a process in which F dot and G are identically 0 is called an equilibrium process. So a process, maybe I should say a thermodynamic process, in which F dot is 0, G is 0, is called an equilibrium process. And we will denote that by putting an E, putting a bar and then put an E behind it, or ahead of it. So what we have seen is then that R equilibrium should be 0, and the maximum value of R occurs in the equilibrium process. So what is delta R over delta F dot IL in the equilibrium process should be what? 0, and delta R over delta GL in the equilibrium process should be 0, and delta square R over delta F dot IL delta GM evaluated in the equilibrium process. What should be this thing? You are saying 0.
No,
No.
less than, less or equal 0.
Remember, this thing is maximum there. So yes, it should be less than or equal to 0. So it should be negative semi-definite. Should be negative semi-definite. So let's evaluate the first term. The R in the equilibrium state is 0. Let's evaluate this quantity delta R over delta F dot. So what do we get? Delta R over delta F dot. So we get rho 0 delta phi over delta FIL minus T tilde IL plus I will have two more quantities, which is really like you differentiate T tilde with respect to F, but before I do that, I have to change this I and L to something else because I'm differentiating with respect to IL. So otherwise I will get too many I's. So I change this I to J and this L to N. And same thing here, if I differentiate it, I will get delta QL. Well, let us change L to N. So delta Qn over delta F dot IL Gn over theta. And now, remember, we have to evaluate this in the equilibrium configuration, equilibrium process. This thing is not always zero. This thing is zero only in the equilibrium process. So when you evaluate this in the equilibrium process, which means F dot is zero and G is zero. So this is equilibrium, and this will go away, and this will go away. So that should be zero. Does it make sense? Yes?
That first term is with respect to F dot, correct?
No. Oh, sorry. The first term is no. Yeah, but this was not with respect to F dot because there is an F dot here. The derivative of phi is with respect to F, not F dot. Because there's an F dot here, right? The derivative of phi is with respect to F, not F dot. So what do we get? We get that equilibrium value of the first Euler-Kirchhoff's test tensor equals rho 0 delta phi over delta phi L. And I don't need to put equilibrium on the right side because phi does not depend upon F dot. And phi does not depend upon G. Phi does not depend upon F dot and phi does not depend upon G. So there is no need to put equilibrium on the right side. Am I making sense? There is no need to put this E because phi is not a function of F dot and phi is not a function of G. Does it make sense or not? So the equilibrium part of stress, which means when F dot is 0 and G is 0, the equilibrium part of stress can be determined from phi. So the equilibrium part of stress is a function of F and theta. The equilibrium part is a function of F and theta, not the non-equilibrium part. We are talking about viscous materials. So the response depends upon F and F dot. So we are going to write our stress tensor T as the sum of two parts, equilibrium plus non-equilibrium. So maybe I should denote equilibrium by little e and non-equilibrium by little ne. So how will we define a equilibrium process? How will one define an equilibrium process? I mean, I already defined for you 5 minutes ago. So I'm just asking you, how will one define an equilibrium process? Yes, George? When F dot and G are 0. So when we are writing this, in this case, what we are saying is that this stress is a function of F and theta, but this one is a function of F dot, theta, and G. And now, let's go back to our entropy inequality. Let's go back to this one, which I think, yeah, we had simplified it to this one. So what we have here is rho 0 delta phi over delta FIL dot minus T equilibrium plus T non-equilibrium plus Qn Gn over theta is less than 0. So all I'm doing is substituting for T tilde equal to T equilibrium plus T non-equilibrium, and this term cancels with that. So what we end up is that T non-equilibrium IL F dot IL plus Qn Gn over theta is less than or equal to 0. So the equilibrium, the non-equilibrium part of the stress tensor, contributes towards the entropy production, you can say, or contributes towards the irreversibility of the process. Irreversibility means you don't have equal to 0. You have less than 0. You have strict inequality. So both heat conduction and viscous effects contribute to irreversibility. You cannot reverse the process. You cannot recover the work done, which is lost in producing the entropy through viscous effects and through heat conduction. There are other results we could derive from here, but I'm going to stop and go to the next. I'm not stopping in the sense of dismissing the class. I'm stopping in the sense of whatever we can get from the entropy inequality. We can get some more results, but I'm not pursuing that now. So what is the next thing the constitutive equation must satisfy? Josh said they should satisfy entropy inequality, which is good. Now what I should say, which is excellent. So what is the next thing the constitutive relation must, there is no choice, okay? They must satisfy besides the entropy inequality. Yes?
Balance of internal energy?
No, sorry, no, that's not it. Yes, principle of material objectivity. They must satisfy the principle of material objectivity. Okay? Sure.
So you're saying that he satisfy the balance of internal energy because it's already satisfied in the equations that we have up there, or I don't understand why that's not.
But you are not present.
Sorry, I don't understand why balance. I mean, I see why material objectivity is on the list, but I don't understand why balance of internal energy isn't on the list.
Okay. The balance of internal energy will be satisfied when you solve for temperature. See, balance of mass, balance of linear momentum, balance of momentum, and balance of internal energy are satisfied when you find the temperature and the displacement or the velocity field and the mass density. In our discussion, we have assumed, okay, it's a hypothesis that the sources of internal energy and the body forces, fictitious body forces and fictitious sources of internal energy are available to us, so that no matter what displacement field or mass density or temperature field you think of, you can find those body forces and internal energy to satisfy the 4 balance laws. So it's not that they should not be satisfied, but the assumption has been made that the body forces and the source of internal energy are available to us to do that. In real life, that may or may not be the case. So in real life, we will find the admissible temperature field and the admissible space field. And that's a part of the job. However, as far as constitutive relations are concerned, we are assuming that that is the case. Another school of thought is that you assume there are no sources of body force and no sources of internal energy available to us. Okay, so 0 sources of internal energy, 0 body force, and then say that the entropy inequality must be satisfied. And that gives you the same set of results, except the algebra may be a little bit more involved. For the materials we are studying, if you study different kinds of materials which are more complex, you may get different results. It's possible. However, what we are studying is roughly from 1950s or 1960s, even though in 1960s the same school of thought that there should be 0 forces, 0 source of internal energy and 0 body forces present be considered. Okay, so it's roughly 50, 60-year-old stuff. But you are right, we do solve for balance laws, but that will be when you are solving an initial boundary value problem. For the constitutive relations, we assume they can be identically satisfied by choosing the body force and the internal energy, and the source of internal energy. And that's why this is called reduced entropy inequality, because R, the source of internal energy, has been eliminated. Okay. You don't see R here, right? Okay, so I think, well, Islam said it correctly. We need the principle of material objectivity. So let's do that. So our constitutive relations are phi is a function of f and theta. Eta we don't have to write, because once you know phi, you can get eta. T equilibrium we don't need to write, because once you know phi, you can get T equilibrium. So the next one is T non-equilibrium, which is a function of f dot, theta, and g. And Q is a function of f dot, theta, and g. So what is the principle of material objectivity? That you take the reference configuration, you apply f, theta, f dot, and g to it, and you get the present configuration. Now, on the present configuration, if you superimpose a rigid body rotation, then the free energy of the body should not change, and the stress tensor should transform properly, and the heat flux, this is per unit undeformed area, that should not change. So what we are doing is, in this green configuration, green is x star, that's obtained from the x by a rotation. So this is time t. xj of xlt. I made the mistake of leaving the lid off of the pen, so it's dried out. So that's the principle of material objectivity, is that if you consider a superimposed rigid body rotation, this O is an orthogonal matrix, which means O transpose equals O inverse. Determinant of O is plus minus 1. Plus 1 means you are going from right-handed coordinate system to a right-handed coordinate system. Minus 1 means the two observers have different coordinate systems. One has left-handed, the other has right-handed. Okay, so what will happen to F star then? So you differentiate both sides with respect to capital XL or uppercase XL. So you get OIJ, which is a function of time, delta XJ over delta big XL. So you get F star equal to OF. Okay? So you get F star equal to OF. What about F dot star? Actually, what I'm going to do is, I'm going to, since we know that F dot star, F inverse, is velocity gradient, or F dot star inverse is, since we know that F dot F inverse is velocity gradient, right? So I'm going to change this dependence upon F dot to L. So you can substitute for F dot equal to LF. So we are going to change this dependence upon F dot to dependence upon L. L is velocity gradient. See, it depends upon F dot, but F dot is LF. But F is already there, so you don't need to write F again. Remember, we are not giving any specific form here. All we are saying is it depends upon F, it depends upon F dot, it depends upon theta, and it depends upon G. Now we are saying it depends upon F, it depends upon L, theta, and G. There is no specific form given there. So what I'm going to show you is that dependence upon L is through the stretching tensor D rather than the spin tensor W. Okay, that's the whole exercise. The rest of the 5-7 minutes, I hope I can finish it. The whole idea is to show you that dependence upon L is really dependence upon D rather than W. Okay, so that's what I'm going to do now. So L star is F star F dot but what is F dot? That's O dot F plus OF dot, chain rule. F star, if you differentiate this with respect to time, you get O dot F plus OF dot. F star inverse will be F inverse O inverse. And when you take the inverse, you change the order. So this becomes O dot, O transpose, because F inverse is identity. O inverse is same as O transpose, plus O F dot F inverse O transpose, and this is D, L is D plus W, L is D plus W, So L star is D star plus W star. D is stretching tensor, and W is the spin tensor. Velocity gradient is equal to D plus W. D is the symmetric part, W is the skew symmetric part of velocity gradient. So it's O dot, O transpose plus O. F dot F inverse is L, which is D plus W, O transpose. So this is O dot O transpose plus O D O transpose plus O W O transpose. Okay, now is O dot O transpose symmetric or skew symmetric? O dot O transpose, remember, O is orthogonal matrix. So O transpose is identity, and if you differentiate it, you get O dot O transpose plus O dot transpose equal to 0. I don't know how else to write 0 now because I have O on the left side. Differential of 1 is 0, right? Therefore, O dot O transpose equals minus O dot O transpose. So it's skew symmetric. Take this to the other side. So O dot O transpose is skew symmetric. It basically gives you the angular speed of one frame of reference with respect to the other one. So in this equation then, equate symmetric part to symmetric part and skew symmetric part to skew symmetric part. In this equation, equate symmetric part to symmetric part and skew symmetric to skew symmetric. So we get D star equal to Q dQ transpose and W star equal to O dot O transpose plus OW O transpose. I have not used the principle of material objectivity yet. All I have done is shown you the transformation laws for W and D. So now I'm going to use the principle of material frame indifference. What the principle of material frame indifference says is that if I look at this T, non-equilibrium, tilde, sorry, I should put tilde also here, because I have tilde on the left side, so I should put tilde on the right side. So this, what it says is that F, if I put F L star theta, G doesn't change. What should happen to my stress tensor now? In terms of if I have, say, one person, so I know Pierce and Fred work together, so Pierce uses F, L, theta and G, and Fred uses F star, L star, theta and G. Now they compare their notes. So they have, each one gets 9 components of this stress tensor. It's not symmetric. We are talking about first Euler-Kirchhoff stress tensor. This is a tilde one. It's first Euler-Kirchhoff stress tensor. So each one has 9 components. And they want to compare their notes now. Do they have the same answer or not? So how should the numerical values of each one of these 9 components be same? They have the same relationship for T hat, tilde, and one plugs in F, L, theta and G, the other plugs in F star, L star, theta and G. So when they want to compare their nodes, how should the two components be related? Through an O. Very good. Because one is using a starred frame, the other is using an unstarred frame. And remember now T, if you write in terms of components, it has two indices, I and L. I refers to coordinates in the present configuration, L refers to coordinates in the reference configuration. We are not changing the reference configuration. We will do that on Wednesday. Okay, we are not changing the reference configuration. All we are doing is changing the present configuration. So we just got one O here. So like Ti star tilde should equal O Ij Tjl tilde. So if either Fred or Pierce, they transform their coordinate system through this, transform the 9 components through this relation, then they should get identical values. Or the components evaluated by Fred and Pierce, they should be related by this relationship. And if it is, then the constitutive relation is objective. If it is not, then you go back to the chalkboard. It's not objective. You cannot use it. Okay? So now, I replace this F star is OF, L star is O D O transpose O. Do you mind staying for another 3 minutes? This is 12:07. Now I realize our connection will be good till 12:20. So is it 3 minutes more okay? Okay, I'm almost done. So it's ODO transpose plus OWO transpose plus O dot O transpose. So that's what L star is. Theta and G, that should equal O T tilde and E of F, L, theta and G. All we are doing is plugging in for F star and plugging in for L star. And just like so, now we make a choice of O and O dot. So we choose O. Simple choice is identity. Identity is an orthogonal matrix. Its inverse equals its transpose. Its determinant is 1. And I choose O dot equal to minus W. Remember, O dot O transpose is a skew symmetric matrix, but now O is identity, so I take O dot. You can choose the function and its derivative independently. Okay, you can choose your velocity and independently of your position. Slope has nothing to do with the value of the function. So if I do that, what happens to this term? OWO transpose, because O is identity, so that's only W. O dot is minus W, so this thing becomes 0. So what we get then is the T non-equilibrium F, D, theta and G is same as T non-equilibrium F, L, theta and G. So really the non-equilibrium stress does not depend upon velocity gradient, but it depends upon the symmetric part of velocity gradient. And that's what you see in Navier-Stokes fluid. So it depends upon the symmetric part of velocity gradient. It does not depend upon the spin tensor. You don't see spin tensor in the Navier-Stokes equations. So T, the non-equilibrium part, depends upon, it does not depend upon L, but it depends really upon D, the symmetric part of L. And that is given by the principle of material objectivity. Okay, so thanks, and I think I can leave these slides on for a few minutes if anyone was not able to copy it. Let me know which page you were not able to copy it. Few questions, okay?